In 13a, you're told that the function y is equal to 4x squared plus kx minus 5 has a gradient equal to 4 at x equal to negative 2. Find k. Now, I know the derivative there is going to be 8x plus k, and when x is equal to negative 2, dy on dx is equal to 4. So therefore, 4 is 8 by negative 2 plus k. K, therefore, is going to be 20. Question B, you're given the generic format of the quadratic there, general parabola. So we're going to take the derivative and solve at the turning point. Then dy over dx is equal to 2a x plus b, which is 0. So therefore, x is negative b over 2a as your answer. Now, when it comes to C, this is a question that is best off firstly looking at via your graphics calculator. Now, it suggests it always has a positive gradient. So we have a look at the graph there. You'll notice that the gradient goes from positive 0 to positive there. There seems to be a point of inflection there. Could actually almost be a point of inflection. I'll just see if that's the case, because I reckon there's a point where it's going to be 0, not always positive. So we'll see if there's a point of inflection there. Yep, so we'll see there is a point of inflection. Essentially, though, always positive. Now, if you think about it, when I produce a graph of that function, a graph of the derivative of that function, it should always be positive if that is the case. Now, the derivative function is going to be 3x squared plus 18x plus 30. We'll have a look to see what happens there. We'll graph that on the same axis. And you can see there that that takes a turning point form, and always positive there. If I do the analysis, the turning point, I want the minimum in this case. You can see, I'll have a look at the correct graph, that I've got a minimum at negative 3, 3. So it's always positive. I'll rewrite that equation in the format of its turning point notation. Halving and squaring it is x plus 3, all squared there. So 3 lots of that is going to be 30, take 27. And that will give us plus 3. As the function is always positive, the gradient is always positive. That tells us that obviously the gradient of the function is always positive. And a very, very rough sketch graph using the gradient to find out information about the gradient function, to find out something about the generic format of that equation. Very, very neat.